Okay, so welcome everyone to this joint webinar of C12G and Hedera technology. We are going to start with a brief presentation of OpenNebula and its key features, followed by a presentation of Kanopya and then a live demo that will show how Kanopya and OpenNebula complement together. And then we'll have a brief session of 10-15 minutes of questions and answers. So the aim of the webinar is to describe OpenNebula, your cloud management platform, and how it can be complemented by Kanopya to attain the highest level of infrastructure optimization. So I will start with a brief overview on what's the OpenNebula project. So the OpenNebula project started in 2005 with the DSA research group researching in cloud computing. And the first technological output of this research was a technology preview of OpenNebula that went out around 2008. From there, the OpenNebula team started making a release cycle more or less frequent, and major Linux distributions started to building packages for OpenNebula in their flavors like Ubuntu, Debian, OpenSUSE, and the latest Fedora one. Around mid-2010, a commercial spin-off of the research group was created, C12G Labs, which nowadays is the company behind OpenNebula that funds the development of the product and also gives professional services and professional support to OpenNebula deployments. Okay, so for those of you that don't know already, what is OpenNebula? Well, OpenNebula is a cloud management platform, meaning that it helps you build a virtualization layer on top of your physical infrastructure, and thus helps you to create a private cloud with your physical servers. There's a lot of benefits of running your services in a virtualized environment, like for instance, the elasticity, and also the resource optimization. So this is one of the main objectives of OpenNebula, helping you to cloudify your infrastructure. Although it's mainly intended for private clouds, it also features public interfaces to enable you to offer your infrastructure to external users. And also it's able to build hybrid clouds. We'll see about this a bit later. It just basically means that you can outsource your computing needs to external cloud providers, like for instance, Amazon EC2. So why should you use OpenNebula? There's a wide range of reasons why you should at least try it out. For first, it's open architecture and open code product, so it's an Apache license. You can download it with any compromise and try it out in your infrastructure. And it also features open interfaces, which at the end of the day means that you won't you won't find yourself in a vendor locking. It's also a very light product, so it's basically a C++ core that is very optimized. So it's highly efficient in the resource utilization. Sorry. It also features an adaptable architecture, so everything is based on plugins. So it's quite easy to support new, for instance, hypervisors, or to integrate with existing components in your data centers. It's also a mature technology. It's been around for over 7 years now, so it's quite intensively tested by our user base and also our community. It features standard interfaces, so it's interoperable with other clouds, and it can also be accessed with any tool that speaks AWS EC2 interface or the OCCI OGF recommendation. It's an enterprise-ready product, so single installing and update process, and also has support for various platforms. And what will take more of my presentation will be its features for data center virtualization. Okay, so we'll start with one of the most important features of OpenNebula. It's the variety of storage models. So as you can see here, a single instance of OpenNebula can control, a single instance of OpenNebula can control different clusters, so cluster A and cluster V1 and cluster V2. And more importantly, it can manage more than one data store. So you can devote one data store per cluster. So a data store is the one that's going to serve the images for your virtual machines. And so you can have different data store for different clusters. In this way, you can sort of prevent the major bottleneck of cloud infrastructures, which is the input-output of images and also virtual machine disks. Also, these data stores, they can be heterogeneous, meaning that OpenNebula supports different storage backends. So you can have an NFS storage-based storage model, or LVM-based, or iSCSI, or Ceph, or ClusterFS. There's a broad range of options you have. So in this way, we can see how the modular architecture of OpenNebula is able to accommodate a broad variety of use cases, and also it helps with integration with other components in your existing data center. Another interesting feature of OpenNebula when it comes to large-scale deployments, it's the ability to manage multiple zones. We understand a zone as an instance of OpenNebula, so you have different data centers in different administrative domains on different geographic locations. You can still have a centralized view of all your different data centers through the OZones component. Another key feature of OpenNebula at the time of managing resources is the ability to create virtual data centers. So basically, a virtual data center is a subset of resources of your local infrastructure resources that can be grouped and offered to the figure of the virtual data center administrator, which in turn can create users that make use of this subset of resources. So it's a way of compartmentalize and in a way, creating a multi-tenancy environment in your local infrastructure. Another benefit of OpenNebula is the ability to use any of the OpenNebula apps. There are also Apache license. You can download it and install it in an OpenNebula distribution. And in the coming OpenNebula 4.0, it's going to ship with the OpenNebula distribution. So it would be easier to try them out. So at the moment, we have currently 3 OpenNebula apps. One is the App Flow, which basically helps you manage a service as a set of interconnected virtual machines as a single entity. The App Stage, which lets you perform automatic installation and configuration of software stack through integration with chef recipes. And also the App Market, which helps you to build a centralized catalog of cloud applications to share and distribute across different OpenNebula instances. Okay, one of the other key benefits of using OpenNebula is the ability, and this I think is quite unique in the cloud management platform arena, to create hybrid clouds, meaning that when your local infrastructure is saturated and you cannot satisfy a service peak demand, you have the choice with OpenNebula to outsource some of this compute capacity to Amazon. So virtual machines will be launched in Amazon, provided that, of course, you have a valid Amazon EC2 account. But OpenNebula is capable of managing both your local infrastructure and the remote infrastructure. And you can set up policies on the placement of VMs, depending on how much money you want to waste, or what's the quality of service that you want to give your users. Okay, so finishing with my part, I just want to share with you some of the added features that will be present in the upcoming OpenNebula 4.0 version. one of the most important ones in terms of effort will be the facelift we are doing to Sandstone. So if you're familiar with Sandstone of 3.8, you can see that's a great style improvement, or at least change, but also some added functionality, like the ability to manage clusters in a more efficient way, or the ability of managing a resource template in wizard-like mode. I think it will make users a bit more easy with the management of a cloud. Also, OpenNebula 4.0 will feature snapshot support, hot plugging of network interfaces to running VMs, also hot plugging of disk saving while the VM is running, so you can snatch a disk from a running VM. It's up to you really to make sure that the operating system is not writing or corrupting the disk at that time, but the possibility is there. Also, the ability to do vertical scaling of VMs, so adding more RAM or more CPU once the VM has been defined. Action scheduling, which I think it's quite useful. So you have the ability to program your actions, like, for instance, please stop this virtual machine next Saturday 9 a.m., for instance, and then bring it back again Saturday afternoon. So you can program these different actions with the OpenNebula scheduler. There's been some improvements in the command line interface as well, and a new set of storage drivers, in this case, to manage theft exports. So I think I'm done with my part. So I will pass now the screen to our colleagues at Hedera.
So thank you, Tino, for this presentation. I'm Jeremy Bourdon, CEO of Hedera Technology. I'm here with Antoine Castin, CTO. Hi. So we will begin by a short presentation of our product Kanopya, and after that we will do a live demo with Antoine of Kanopya. So we are very pleased to introduce you Kanopya, developed by Hedera Technology. We are a cloud software editor founded in 2009, based in Paris. We are 15 employees. Our mission is to give freedom and flexibility to build scaled cloud in minutes. We pilot the different layers of the IT stack, hardware, storage, VM, and IaaS, to create automated, orchestrated, and scalable services. We have developed Kanopya for IaaS solutions like OpenNebula and other one to bring them new innovative features. So we are very happy to work with C12G on such enterprise-ready and flexible cloud platform like OpenNebula. So what is our customer pain and gain? So nowadays we ask IT department to do their task faster with less budget and more flexibility. Basically, we give them the means to reach their target. So with Kanopya, our customers industrialize their infrastructures by creating services and fasten time-to-market service delivery. Added to that, our main goal is to optimize infrastructures in order to reduce costs, OPEX and CAPEX. Our Kanopya Smart Workload Manager, which is one of modules of Kanopya, increases efficiency, service assurance, and application performance. To reduce costs in the run, we do more than turning on and off. We find out the best configuration as possible according to your SLA and requests. Furthermore, identifying these functions can be long and fastidious due to a ton of logs. So not only we do monitor resources, but we also solve root cause problems automatically and in real time. Kanopya delivers an intelligent and automated controls module to guarantee performance for your OpenNebula platform. So how Kanopya works? Kanopya works with the virtuous loops. Once a cycle is finished, another one begins. It can be set from every 5 minutes to once a day, depending on what you want. First, we monitor the resource that we pilot, like compute, system, and applications. Second, the information goes through our intelligence algorithms. We analyze data, we correlate them in order to find out the best configuration to determine the best action. Kanopya's performance analysis works with several algorithms and powerful engine to guarantee SLA while optimizing occupation rates. Our workflow and deployment manager makes sure operations are made successfully and in the right time. Our deployment managers work with Puppet to automate configuration management. So what is the different module of Kanopya? Kanopya first is a modular software. So you can use every module depending on what you want and what is your needs. Each module has a specific know-how and corresponds to a particular needs. The first one is the smart workload managers. For instance, if the intelligence of our solutions with many algorithms like a rule engines, a correlation engine, and historical analysis and learning. For example, what is historical learning? For instance, imagine that all your sales representatives connect themselves to your CRM every Monday at 11 o'clock. The solution will learn automatically and will deploy all the necessary resources and anticipate the request increase. The VM Lifecycle Manager is designed to optimize virtual environments like operation, like live migration, hot scaling, CPU and RAM, and monitor the activity of each VM to avoid resource waste. You can deploy different IaaS and manage different IaaS like OpenNebula. The Orchestration Manager is the one making sure your operation go well, creating the right workflow at the right moment. The Cloud Service Portal is an innovative way to build services by gathering different infrastructure policies together. You can customize your billing scenario depending on your business model. The system will integrate it, respect it, and apply it. Therefore, you can follow your client's consumptions and offer them the best option to use it. The Full Stack Deployment Manager is the module designed to bring automation to the different layers of your IT stacks. It's based on the Puppet agent. And the last one is the Core Engine. It's the glue that combines together the different modules. You can either add them up to have a solution or use them independently to complete your IT management tools. So just to describe you a use case. So our use case is one of our customers which work in the industry sectors. He has deployed OpenNebula in Kanopya infrastructures. Our customers deploy and manage identity and access management softwares for different clients and customers. Their customers are dispatched everywhere on the globes, and some customers are in Brazil, other customers in North America, other one in Japan and Asia, etc., etc. So his goal is to first automate a KVM and OpenNebula provisionings based on the Cisco and Dell environments. He wants to simplify the management of the all networks with 20 networks, 200 VLANs, and 4 physical data centers. But the main point that he wants, because he has not a lot of infrastructures, he wants to move dynamically hardware from one IaaS to another IaaS depending on the fluctuation charge loads. For example, he wants that the hardware used by the Brazil zone switch to the Asia zone every night. So the benefit with Kanopya is to have a scalable private cloud that adapts itself depending on the application request. And for results, we decrease the time to provision IaaS from 8 hours to 45 minutes, the time to deploy VM from 3 hours to 12 minutes, and 30% of their compute nodes migrate every day from one IaaS to other IaaS, depending on the load of the infrastructures. So this is one of our typical use case based on OpenNebula and Kanopya. So now, the best thing to do is to show you Kanopya, and Antoine will show you what Kanopya is able. And if you have any questions, don't hesitate to write it by the chat, or by raising up your hand.
Okay, hello everybody. I'm Antoine Castin, the CTO of Hedera Technology. For this demo, I set up the following environment. So we use with this instance of Kanopya 3 different servers with Linux NAS system storage and flat network to combine all this infrastructure. On this compute node, we deploy OpenNebula on Hedera, and we created 2 different services. So to begin, I will change my screen. We will see the new screen with Kanopya login. I think it's good. So before to begin and login in Kanopya, I have to explain you that Kanopya manage different and complex environments, virtualized or not, and to adapt to complex process and heterogeneous users, Kanopya implement 2 kinds of right management. The first one is a role-based right management with 4 different kinds of users. The Kanopya administrators who configure and manage its Kanopya instance, the IT administrators who register and manage technical infrastructures, your marketing team if you are a hoster, or your business project manager in company who create services, launch it, and manage them. And the last but not least, you have the sales or the operator or the user portal who manage existing services and subscribers. The second right management systems is an entity-based one, which allowing you to define who will manage what. So I will log on Kanopya. So to begin the demo, I will explain you how to manage infrastructure. So with Kanopya, you can register your different servers through directly Kanopya or through an Active Directory. You can use UCS Cisco Blade Manager or Fujitsu one. After, you can register different storage system using a Linux NAS based on LVM, iSCSI, and NFS, or Fujitsu and NetApp are available for Kanopya. Through the network configuration, you will be able to define the different IP pool and IP networks used in your infrastructure and the different VLAN. After, you can create some network configuration explaining to Kanopya how these different networks are plugged in. In the system part, you will register your different operating systems, your applications, and your kernels. So for this demo, as I already said, I deploy OpenNebula IaaS. This IaaS, I can't access this part of my screen. Each infrastructure has its own dashboard. You can review all the main metrics of your infrastructure. So as I said, we have deployed an OpenNebula with 2 different data stores registered on it, and another commitment ratio set to 4 for the CPU and the memory. So we can over-provision our infrastructure 4 times compared to its real resources. Through the hypervisor part, you can review which hypervisor are deployed and which VM is available on it. You can manipulate the different VMs and hypervisors from the screen, but it's only administrator part. So when your IT guys has defined the infrastructure, now your business team or your project manager want to create some services adapt to its customer or to the end users. So to do this, to have the best flexibility, we create two levels of service templates. The first one is a policy. The policies are a templating part of your services. You will be able to define different policies for each part of your infrastructure. The hosting one defining on which infrastructure is based your new service, on a IaaS or physical clusters. On the storage, you will be able to define which storage systems could be used. In the network, you will create a different topology, defining that for your service, you have two or more interfaces used for the internet access, the private access, or VM access. In the system part, you will define which operating system is used and which applications are deployed. The scalability policies allow you to define from which number node to maximum that will be deployed through Kanopya. You can set the priority to. Our most important policy is the billing policy. The billing policy allows you to define some business package like in mobile phone industry. So you are able to define different limits to manage your customer consumptions. In this example, I defined 3 different limits. One on 2 gigs of RAM, one on 4 gigs of RAM, and the last on 8 gigs of RAM. So my user will consume its memory during its life, and we can adapt the best package to its consumptions. And the hoster could give the best build for its consumptions. This is the first case. The second one, for the application who has a periodic activity, like the poker or porn website, you are able to define limits during different day period. So in this example, I defined a first limit at 4 gigs of RAM during the day and 32 gigs of RAM during the night. So my infrastructure will use at maximum 4 gigs of RAM during day and 32 gigs of RAM during night. The last policy for your service is an automation one, and I will explain it during the real use case on a service instance dedicated to a customer. So when you defined all your policies, it was a little long, but you are able now to create easily services taking the different part of your policies and combining it on our services. If you let some blank in your policies or in your services, this point will be asked to the end user from the service portal or to the operator who registers infrastructure for its clients. So, for example, you can let the minimum and the maximum RAM amount set to blank for the instantiation, and depending on your customer, you can choose which is the best amount of RAM to begin its infrastructure. Moreover, through customer configuration, you are able to define a global quota on your customers and set, for example, 10 gigs of RAM for users, and you can have different services, but the total amount of RAM used don't go through 10 gigs of RAM. So our services are created, our infrastructure is registered. Now, how can I manage my different service instances for my customers? So I have 2 examples, as I said, defined on my infrastructure. The first one is Asha high available virtual machine, and the second one is the standard virtual machine services. On each dashboard, you are able to add some metrics and dashboards and customize it. In the different tabs, you can review all the aspects of your instance. You can add new applications from our supported applications and specify what I want to deploy. Kanopya can easily deploying different applications. If I choose to use, for example, the MySQL applications, Kanopya through Puppet will deploy it on a node. Through the resource part, you can review all the VMs or servers deployed for your service, and you can access to the action part, like stopping node, resume it, scale CPU, and hot scale memory, migrate from one host to other, review the configuration, the network configuration, and view a dedicated monitoring part to review its consumptions. In the rules part, you can review fast the different rules and the compliance. I will talk about the monitoring and the rules and in the last part of my demonstration, so I directly go to the events and alert. On this part, I can review all the workflow executed on my infrastructure and see which infrastructure is available and different alerts based on it. I can review the billing policy too. So now we could manage our service instance. Now, how can we optimize it? First, we have different, as said Jeremy, said, we have different solutions to automate and optimize infrastructure. So in this demo, I will only focus on two parts, the capacity planner and the rules engine. The historical analysis and the QA simulator could be talked later. So I'm going back to the IaaS view and explain you a little bit the different features. In our capacity planners, it allows you to deploy your VM on the best hypervisors depending on the load consumptions, on the load distributions, the booking systems, and the configuration constraints. Like, for example, in your network interface defined on your services or your storage access. And if you have compliance node, Kanopya will deploy the VM on it. To aim the best repartition on your infrastructure, in our example, we have 6 VM, 4 in the first hypervisor and 2 on the second one. We create an optimized IaaS workflow, which allow you to pack the VMs on the lesser number of nodes. So if I click on it, all my VM will be live migrate on the more used hypervisors, and automatically it will free the maximum number of hypervisors. And after, I can remove this hypervisor from this IaaS. In this case, it's important to understand that Kanopya allows you to move servers from a IaaS to another. So that's the main part of the capacity planner. I forget to say it is agnostic one, so you can plug it on OpenNebula and OpenStack and VMware. And now I will explain you how our rule engines function. So we have to create some intelligent rule on your infrastructure. The first thing is to define good metrics adapted to your infrastructures. So in my two services, which one composed by 2 VMs and the other composed by 3 different VMs, I already defined different metrics. This is basic metrics based on memory available or total amount, on CPU, and on availability. I can create aggregate metrics for a service combining with statistic method the different node metrics to detect some usage. For example, in this one, I create a matrix to detect problem during the load balance in the infrastructures. So when I create my matrix and I understand it, I can plug on it different rules to automatically deploy or remove or reconfigure applications. In this example, I defined two main rules to auto-scale the virtual machine. For example, the first one, add memory if there is not enough memory on the different node. So on it, I just plug a workflow to add some memory. You can set alert system on your infrastructure, specifying which user will be notified by the infrastructure, and you can specify that you want to validate the workflow triggering. I will give you another interesting example. In this infrastructure, I can show you, to begin, that with our automatic workflow, we manage the size of the VM dynamically. Here, you can view the global amount of memory, and it changes depending on the load on the infrastructure. In my second example, I will show you how Kanopya could manage elasticity of your service. And on it, we have, for example, here an Apache application deployed. And when the load on the different VM instance attached to the service is increasing, Kanopya will automatically deploy new nodes through its workflow. Like you can say here, if the mean memory available is lesser than 252 megabytes of RAM, we can add node. And automatically, Kanopya will deploy new node and reconfigure the load balancer and the applications on all the nodes. So to conclude, Kanopya allows you to define, to register your infrastructure, to define services, value-added services, to manage it, and to optimize it. So if you have some questions, I am free to answer to it.